So let's talk about these IP addresses in more detail. You remember that the IP address is a 32-bit number and that we convert it to decimal, don't we? Yeah, we convert it to decimal because we humans like to work in decimal. Now, turns out it's really easy to convert decimal to binary and binary to decimal. It's all based on this powers of 2 chart. Yeah, it's all based, how you do the conversion, on this powers of 2 chart. 2 to the 0, anything to the 0 power equals 1. 2 to the 7 would equal 128. In fact, this table, you'll see, trust me, this table is going to come in critically important for us, and we're going to memorize this table, and we're going to build it on our scratch paper the minute we start our ICND 1 exam. Yeah, the minute I start my exam, I go to that scratch paper, and this is what I do. And I want you to memorize this as well. I want you to do it too. So I go to my scratch paper, and I go 2 raised to the 7th, 2 raised to the 6th, 2 raised to the 5th, 2 raised to the 4, 2 raised to the 3, 2 raised to the 2, 2 raised to the 1, and 2 raised to the 0. I then draw lines between these, and a line underneath, and then I show the decimal equivalent. 2 raised to the 0, 1, 2 raised to the 2, 2, 2 raised to the 2, 4, 8, 16, 32, 64, 128. Notice how easy this is. It starts at 1, and then you just double it as you go that way. Why don't you grab some scratch paper right now, and why don't you practice building this important table? Yeah, go for it. Do it right now. I'll build it again. 2 raised to the 7th, 2 raised to the 6th, 2 raised to the 5th, 2 raised to the 4, 2 raised to the 3rd, 2 raised to the 2nd, 2 raised to the 1st, 2 raised to the 0. Two raised to the 1 to the 0 is 1, 2, 4, 8, 16, 32, 64, 128. Remember, you just got to start right. I almost messed that up. You got to start at the right number, and the right number is 1, and then double that value. This is the first step that we're going to go through together in subnetting. We'll get into this, in great depth next time. But for right now, we're going to start slow. We start with this conversion chart. And this conversion chart is going to prove critical for us to engage in our subnetting later on. All right, in fact, let's see how we can go ahead and leverage this table. Watch this. Let's take a look at taking a decimal number and converting that decimal number to binary. Okay? They give us the number 35. And they want us to convert that number to binary. Notice right up here they have our conversion chart. So there's our conversion chart. All you do to convert from decimal to binary is you examine, can you subtract this number from the number you are converting? Okay, can you subtract 128 from 35? And the answer is no. I mean, you could, but you'd have a negative number, so that doesn't make any sense. So a 0 goes in the first bit position. Notice, by the way, these are our 8 bits in an octet of an IP address. Remember we talked about that? How an IP address is 32 bits and we break it up into 8-bit octets? So we are doing the conversion of an octet right here. And I see many of you in the audience have already solved this. Good job. Some of you have already solved this. You're ahead of the curve. You're already able to do these calculations. That's great. Can we subtract 64 from 35? No. Can we subtract 32? Yes. So notice we have a 1 in this bit position. Can we subtract 16 from the remainder? What's the remainder? Well, 32 from 35 gives us a remainder of 3. Can we subtract 16 from 3? No. So we keep going. Can we subtract 8 from 3? No. Can we subtract 4 from 3? No. Can we subtract 2 from 3? Yes. That gives us a remainder of 1. And of course, we can subtract 1 from 1. So 35 in binary is 001000111. It's the result of our little subtraction exercise that we did. And so many of you chatting in that correct answer. That is just awesome stuff. Great work. All right. So are you ready to try one? Well, first of all, let's see binary to decimal conversion. It's even easier. Dan asks, if the place value is doubled starting with 1 going to 128, is the base exponent necessary? Yes, Dan, you'll see later on. Yes, great question. You will see later on why we write this out. Yeah, Dan's like, if you don't use it, why are you even writing it out? I mean, it seems to me, Anthony, all you used was this row. Well, you'll see, Dan, this is going to come in really, really handy that we have that written out. Okay? All right, so let's see going the other way. It's even easier. Riz asks, by the way, in the exam, would you have to put the initial zeros in front of your answer? Yeah, in the exam, it's going to keep this to an octet. So you want to go ahead and show all 8 of the bits. You'd want to show all 8 of the bits. That's how they would most likely present it in the exam. Yes, because we're dealing with IP addresses. Okay. Well, let's take a look at the other way around. Let's go from binary to decimal. So here, if they give us a number in binary, look how easy this is. We're just going to do addition. We just take all of the decimal values in those positions and we add them together. The 128 is on, the 32 is on, the 16 is on, the 8 is on, and the 1 is on. We add those up, and we get 185. And again, we have students chatting in that correct answer. Awesome, you're ahead of the curve. You're already able to go ahead and do this exercise. That's awesome. You've got a head start on subnetting when you can already accomplish these binary to decimal conversions and these decimal to binary conversions. Great work. Now, let's make sure you can all do this. Good luck. This is what you would see in the exam, for instance. What is 187 converted to binary? Good luck. I'll go ahead and play some music that we can use for thinking. That's getting annoying even to me. Let me shut that music off. And I see lots of you still working on this out there. Good. All right, I think everybody's done. Everybody's ready to see me walk through how I would solve this in the exam environment. Are you ready? Here is my chart. As you know, I wrote my chart on scratch paper at the beginning of my exam. So I've got my chart on scratch paper at the beginning of my exam. I'm ready and raring to go. They gave me, what did they give me? Let's see. 187 converted to binary. So I'll go ahead and write 187 up here and circle it. Can I subtract 128 from 187? Or, yeah, exactly. Can I subtract 128 from 187? Yes, I can. Let's see, that would be 9, and that would be 59 left, right? Boy, I wish my daughter was here because this is the kind of math that she is doing in the 5th grade. All right, so this is a 1 in that bit position. By the way, you can now jump to the example, and you could eliminate any of the options that don't have a 1 in the first position, but unfortunately, they all do. Yeah, unfortunately, they all do. So that didn't help us narrow it down at all. The fact that we discovered there is a 1 in the first bit position. Can we take 69 from 59? No, so we have a 0 in the next position. Can we take 32 from 59? And the answer is yes, and we have 27. So we're going to put a 1 here because we did use that in the subtraction. Can we take a 16 from 27? The answer is yes. So we're going to put a 1 here. That leaves us with, let's see, that would be 18, right? No, what am I saying? That would be 11. Can we take 8 from 11? Yes, we can. That would leave us with 3. Can we take 4 from 3? No. But yes, we can take 2, and yes, we can take 1. So I circle this so I can see it clearly, or just write it over again. The answer, 1, 0, 1, 1, 1, 0, 1, 1. We go back to the problem. 1, 0, 1, 1, 1, 0, 1, 1. The answer is indeed B. Awesome. What's great about your problems involving subnetting is that they are math, right? It's black and white. You either do the math correctly and arrive at the correct answer, or you do the math incorrectly and arrive at the incorrect answer. It's total black and white. There is no room for interpretation here like there might be with some of your multiple choice, involving facts, right? There's no interpretation that you could mess up here. It's, once you can do the math, you can do the math. In fact, most of my students initially are afraid of the subnetting questions in this exam, but then once they've been through my subnetting class a couple of times and they're acing those, they crave math-based questions in their exam. That's the type of question that they want. And Riz says, yeah, you could go the other way to confirm it. You could add it up to make sure it works out, and that's exactly right. All right. What is 1001101 converted to decimal? Good luck. boy. Now, addition is easier than subtraction for me. So, wow, this one's really, really easy. Okay, you remember I'm going to have my conversion chart, right? So we've got 128, 64, 32, 16, 8, 4, 2, 1. And we are going to add the appropriate numbers, right? 128 plus 16 plus 8 plus 4 plus 1. So we just need to add those numbers up. We've got 14, 22, 26, 27. That's 157. Yep. It is a simple action or simple act of addition that we do to arrive at the number in decimal. Why are we going to be doing this? Well, because we are going to get into subnetting. And you might think, Anthony, why do we even have this subject of subnetting? And it's because we can't take our network and just build it using layer 2 switches, can we? If all we did was have layer 2 switches, we would have way too many systems in one collision domain, right? Let me rephrase. We can put them, they're each in their own collision domain. But the point is, we could start getting too many machines all on one network, right? Here's the main problem. And sorry that I'm stumbling a little bit here. I'll get better. Watch. Every one of these devices is in its own collision domain. We know that. But guess what? Each one of those devices is all in the same broadcast domain. So we want to not only give everybody collision domains, but we want to be able to break the network up into, let's say, 2 different broadcast domains. So maybe we put these 2 in their own broadcast domain, and we put these 2 in their own broadcast domain. In order to put people in their own broadcast domains, we put them in different IP subnets. So each is going to be put in their own IP subnet. Specifically, these 2 machines will get one subnet, and then these 2 machines will get one subnet. And that's how we can make sure that we don't have an issue with too much broadcast. Now, great question in the audience. Hey, when it comes to those calculations, can we use calculator in the exam? No. No, you cannot use the calculator in the exam. But what you can do when you're practicing is you can use a calculator to double check your work. Yeah, that's a real good idea when you're practicing, right? So we'll come in, we'll grab a calculator, and we'll go in and we'll say 187 in decimal. What's that in binary? And it says, okay, in binary, that's 101111011. And we can double check our work in a calculator when we're practicing. Notice I converted the standard Windows calculator to the programmer calculator, which has buttons for decimal and binary right here. So, we are interested in taking our big network and dividing it up into subnetworks and taking a router and routing between these different subnetworks. What does a subnet mask do? Well, a subnet mask, as you're going to see, simply demonstrates for us what portion of the address identifies the network and what portion of the address identifies a particular host. Remember when I said that this was like 14 Jones Street? An IP address had a street name in it and then a house number. The subnet mask is making sure we know which portion is the host number or house number, and which portion is the street address. So we're going to see in TCP/IP networks that subnet masks identify the network portion of the address. And routers use subnet masks to figure out what is the street address for the delivery of information. So, what a perfect stopping point. When we pick up with our next class session, be sure you can do those decimal to binary and binary to decimal calculations. And then we will go ahead and take that skill and we'll get into the depths of subnetting, and we'll see the types of problems that we can solve using those simple math skills. Thanks again for joining us, and I'll stick around in the Q&A and answer your questions for as long as you like. Thanks again, and see you tomorrow for our next session where we're really going to get into it on subnetting.